All right, so today we want to take a look at how are we going to calculate p-values and test statistics using StatCrunch. All right, so let's share our screen. And let's take a look at the example from our PowerPoint, which says, suppose a poll of 250 randomly selected voters in a large city found that 140 of them favored increased funding for public libraries. Based on this poll, could we conclude that a majority of voters in this city favor increased funding for public libraries? Let's use a significance level of 0.01. So that's our alpha. Our research question is it going to be greater than 50%? Is our proportion greater than 50%? So that's our alternative hypothesis. Remember, the null hypothesis always has an equal sign. All right, we're going to assume all conditions have been met for the central limit theorem for proportions. And then since we have done so, we can go ahead and start doing our calculations so we can draw our conclusion. So in StatCrunch, let's go to Stat, Proportion Stats, one sample with summary. Whenever you're doing a hypothesis test or confidence intervals for proportions, this is where you would like to go. Again, that's Stat, Proportion Stats, one sample with summary. You enter your number of successes of 140. You had 250 people in your sample. You're conducting a hypothesis test, so make sure that's highlighted. You are interested in whether your alternative hypothesis will be greater than. Remember, we're trying to get majority, so we need more than 50%, while the null will just state that it is equal to the 50%. Okay. So at this point, you can compute the results that StatCrunch gives you. It reminds you of your null and alternative hypotheses. It gives you your sample proportion, that's your p hat. It calculates your standard error for you. So instead of using the standard error formula, you can get that here. It calculates your test statistic. There's your Z. And then it gives you your p-value. So we taught this lesson based upon the test statistic or the p-value. You can use either one of them to determine whether you want to reject the null hypothesis or not. I think the p-value is easier to use. And in this case, your p-value is approximately 3%, which is greater than your alpha at 1%. So remember the steps say, whenever your p-value is greater than your alpha, this means your data is statistically insignificant. So in other words, your data did not show you anything you didn't already expect to see because we always assume the null hypothesis is true. Our data is statistically insignificant because the p-value is greater than the alpha. Whenever p-value is greater than alpha, we do not reject the null because once again, we assume the null is true. And therefore, if we always assume it's true and my data didn't show me anything that I didn't already suspect, then I do not have enough evidence to support my alternative hypothesis. In other words, we don't have enough evidence to say we will get majority of the voters to favor increased funding for public libraries. I can't say that I've proved that it won't happen. I can only say that I don't have enough evidence to support that it will increase. All right, so in this case, we're going to accept our null hypothesis and we're going to assume that not going to get enough voters to support this increased funding for public libraries. Okay, so once again, when your p-value is greater than your alpha, you do not reject the null. When you do not reject the null, that means your data is statistically insignificant or insufficient. That means you do not have enough evidence to support your alternative hypothesis. All right, hopefully that was helpful. And I'll catch y'all next time. We'll do this again for means in chapter 9. All right, have a good one.